A very good morning, good afternoon, good evening, YouTube family. This is Amir Mustafa. Today we'll be learning an Azure service with which we can create machine learning pipeline. So we know that we can create lots of model using different various ways in Azure. Today's service is specially dedicated to creating a machine learning pipeline. Let's see how we can do it. Azure did a great job creating this graphical representation. We'll be using it, and the best part of it is everything is drag and drop feature provided by Azure. So let us start. So why we should use this service? There are various ways with which we can create machine learning models. So for creating machine learning pipeline, we have a graphical drag and drop pipeline, and seamlessly we can create a pipeline. Once you'll do it, you'll recognize that this is very friendly, user friendly, developer friendly. The next thing, why is the service in demand? See, today or tomorrow we'll be using machine learning in our application. It depends that whenever if we get a chance to use Azure machine learning service in our project, that point of time machine learning can be created. Machine learning model can be created by various ways. They provide automated machine learning or different way. So pipeline, with the help of pipeline, we can graphically create an experiment and run it. Like in production we see now that if we have a production ready service, sometime it breaks, fails, sometime it successes. We can see logs from there. So let us learn and just do it in real time. Okay. So I'll not go much into the theory. Let's start with the which one? Let me open the service from the beginning. So this is my Azure portal, or Azure portal site. We have to go to a service called Azure Machine Learning. In the last video, what we did was that we had a workspace. Now suppose if I'll assume that you are seeing this for the first time. Whenever we enter into a machine learning, what happens is we create this plus sign. See, I've opened this one previous article also. This will become very handy, or even attach the video. So what we basically do when we enter into a machine learning, the first step is to click this plus sign and create a new workspace. When we click this new workspace, let me take some time also. We enter the resource group which we are adding. Add the default setting workspace name. Here we can write a project name. It is a UAT server. Is it a dev server? So we created this one, dev ML Happy Learnings 76. This was our workspace name. So it is created over here. Once we sign up for that, we get our services over here. So this is called ML workspace. So let us go to the dev. Once we enter into the workspace, the next step we have to do is launch the studio. So what is a studio? See, whatever we will be doing in a studio can be replicated in the application. You can say, Azure says come and test whatever service and feature we have, then we will provide REST endpoint and you can integrate in your apps. So we'll go to the launch studio. So anything which should work over here should work in your application, in our application. Okay. Now, so everything is written over here step by step. You can follow along also, but I will try to make this simple, fast and in the best right approach, right possible way. Okay, so what we have done in the last, so this is our machine, this is our studio, ML studio. We click this workspace and we click launch studio. So in the launch studio, in the left we have lots of things. Automated ML, this is also something which is used a lot. So if you want to understand ML studio, how it works, so the same, we had dedicated video for that, you can see over here. But for today we'll be learning designer, and let's do it. I'll be bringing the studio next to the blog. Okay, so for starting with the designer, so basically what we are trying to do over here, we are trying to create a machine learning pipeline. So let us click the designer. Azure create some sample, what we say, sample pipeline, regression, wide, deep. We will be using a classic pre-built component. Most of the application, they use their application, their own custom pipeline, because obviously in the pipeline we will add data, and data is private to any specific company. Okay, so we click designer, we click the plus sign, and now okay, all right. What will now this thing we have to understand, this is the most fun part of this service. Okay, the left hand side, this section, this is called component section, component of data you can say, and the right hand side is called a canvas. So whatever we are seeing in the left can be dragged to the right, either dragged or click and use component to the right. So basically they have lots of things. Based upon our requirement, we'll choose it and follow along. I will also come over here and add, so you can follow along also in the blog if you miss something. Okay, so we click this plus sign, we reached over here, and first step is click on this data. First step, anything related to machine learning we have to do with the data. So left click over here, we are drag and drop to the right canvas. So it is here. So we can zoom in, zoom out based upon our requirement. 200%, like 75%. Let's do 100% for now. Okay, so we have dragged and dropped this ML data. What is this ML data? Now dev ML data. This is for dev environment, you can say. So what is dev ML data? So ML data is basically the data which we are using. So Azure provides, if you open the Azure site, for learning purpose, Azure provides lots of sample data over here. So we have chosen diabetes dataset. So this is actually there in this data. So let me try to come over here. I'll do the duplicate of this tab. If we click data, if we click dev ML data and we click explore, so we see that we have this data over here. This data is nothing but the sample data provided by Azure. Learning purpose, when you will be implementing in your actual project, production project, they will provide you to upload the data. Not to go much deeper in this, just for now, for understanding purpose, you should note that in the data there will be one data coming over here for you. Okay, this can come either from it is uploaded actually, either from the file, either from the storage account, it will come here. We have to do. So the purpose is we are creating a ML pipeline. It means data is already ready in this stage. So we drag drop over here from left to right. That's all. And team, please ask question if you get stuck somewhere, because I feel if learning is important. So this is dev ML data. Now next step is all right. Anything to show over here? Let's double click this. You can name the data. So whatever in real time, if you see in the real-time project, by real-time project means project which are already in production, its users are using it, there are lots of data over here. So it will be in the real time there will be lots of data, so we have to choose the right one which we want to. We are creating ML pipeline, so we should know that what component we have to add. So we'll for this specific case I'll try to make step by step why this is required, why this is not required. I'll try to make it simple. Okay, so we click right arrow, it will go hide. Now the right side is over here. The next step is to add. So there are few pieces we have to add. The first, we have added the data. So in the component section, I'll just try to give some review. Every logic that you can think of is available over here, which machine learning contains. So if you want to do some data transformation like add column, add row, we are dealing with table, right? So if you want to add column, add row, we can do from here. Don't get into complexity, because in real time when we'll work, all this thing will be given to us. But for understanding purpose, try to think this is some mathematical approach. If you want exponential data, you'll apply exponential. If you want duplicate data, you'll remove duplicate data. You can do there. Some lots of maths, reusable function you can say is there. If you use this, you can do something, add row, add column. For our case, what we are trying to achieve, first you should understand that. I'll take the same example, this one. If this is my phone, okay, so the first time when I buy this phone, I want to apply a fingerprint in it. Okay, you want to apply a face unlock or biometric, what we say, face unlock or fingerprint impression unlock. So what we do, the first time when we do that thing, we have to first set the pass fingerprint in various angle, and then your iPhone or your Android phone, what it does, it remembers it, it stores it. Okay, so that portion of it is called training data. The first time machine is learning, oh, this is the guy, this is the lady whose fingerprint should be recognized. Now if suppose I will come and I am not the owner of that phone, I try to unlock with my fingerprint, it will not unlock, because machine knows that this is not a fingerprint to understand, this is not the right fingerprint. So what actually is happening, think like this is the whole data. The first time when user is trying to set the fingerprint, that is training data, and the second time which we'll trying to utilize those training data to match, like unlocking a phone with the current user fingerprint or face detection. So it is doing extraction. So we have learned now two terms over here. See, you can see over here, we have one training data, that is the time when we are feeding to the machine, understanding, I understand this is the thing you should know, fingerprint, this is, you need to unlock with this. And the second time is extraction, when we come and try to unlock. Okay, so you got the gist at least. Okay, so this is the whole data. Okay, so now in the real time this may contain lots of data, 50k data or 10k data. So the first component we require, we choose component as per a requirement. So the first component we require is split data. Oh man, that searching part is really okay. It is over here in data transformation. I'm searching for the split data. This is the split data. So two way we can do it. Either we can drag and drop here. Let me delete it. Oh, sorry. We click it and delete it. Or we click it and click use component. It will come over here. Both two ways to do the same thing. let me, okay, so this is the split data. This is the second component. So likewise we'll add 5-6 component, and why it is required then we should know. Okay, we have the whole data which is coming from diabetes, this data set. Now we have split data. Why we added this split data? Now it means one portion of the data will go somewhere, the other portion of the data will go somewhere, splitting the whole data, one for training, one for extraction, one for setting the fingerprint, one for detecting, matching with the, for unlocking one, extraction. Now let us double click this. Now Azure provides us with okay, how much you want to, in real time how much we do, that depends totally on the, what we said, totally on the end user itself, how much you want to train. Means like phone, if you buy, you can try with 10 multiple angle, you can add all your fingerprints, 10 fingerprints with all the angle, you can add only thumb and index finger with all the angle. It depends totally upon that, how much you want to. The more you train, the better machine will understand if you try it. So for us, let us do 0.8. It means 80% of the data will go for the training, and remaining 20%, this 80% will be from the first point, and remaining 20% will go to the other point. Yeah, that's it. So we just click the save. Let's see if our feature is done or not. Double click on this parameter. Okay, split is 80% now. I'll try to make this video short. Okay, this is 70% small, 100% only. Okay, split data. Now what do we require next? Okay, so split data we have added. Now next we require logic, right, which is ML algorithm. Say two component we'll use now. One is algorithm and one is model itself. Whenever creating a training a data, machine learning should know, okay, use this algorithm, use that algorithm. Some algorithm it will take, right, like for regression, numeric type of data. Our case is regression. Whenever we have numeric output, it is called regression. Whereas Boolean output true false, it is called classification. So for our case, we'll be using regression type logic. So what I was saying, the next component we'll use over here is, it is called machine learning algorithm. This is very important, you should note. Okay, at least try to no need to remember the complete name. As you do, you'll understand later, but at least we should know now over here is regression. When to use regression? Whenever the output is numeric. See, here we have lots of numbers, data, numeric, some report is there, sample report. So in that case we'll be using regression model. The other type of model is cluster. Clustering means whenever data are added based on some common properties, that is clustering. And finally one is classification, the one which we discussed, either true or false. Will it train today? Can be yes, it can be no, but Boolean output, one yes or no, true false. So for our case, let us use the simplest of the regression tool. In real time, whenever need will come which algorithm to use, that time becomes clear, but for understanding purpose we will be using regression. It is called linear regression. This is our third component. Fourth component is, it is model. Okay, guys, feel free to scroll if you think I am doing very slow. Let me add it over here. See, if we scroll down over here, we will see model training. Yes. Okay, we come over here, we see model. What we are trying to do, we have our data over here. Now we want to split the data into two. Why we want to split the data? Because we have to send some for training, some for extraction. Training means think like setting a fingerprint. Extraction means using that fingerprint to unlock. Now for training, we require we have to create a model. For creating a model, it requires two things. One is ML algorithm, which is linear regression for our case, and the second one is model itself we have to use. So we have chosen train model. Doesn't matter we keep here or anywhere, the later will connect everything. It should be connected properly, just that. Linear model. Okay, we have train model. Sir, piece 4 is ready. Let me do in that same order because we'll be using that now. You can think like this. Okay. And the last two component more we require over here is now we'll be connecting soon this component, just two more component. Now we require score model and evaluation model. Why do we need it? Once training is done, for now think that you have set the password in your phone, okay, fingerprint. Now the next time person will come and try to unlock the phone. Say I am the owner of the phone and I am trying to unlock my phone. So firstly, behind the scene, machine should know, ML should know, okay, machine should have its data ready, right? So it will, behind the scene, it will have the data ready. It will check where it has stored the password. That is the training data for us. Because whenever training data term is coming, think like those things machine knows. Okay, these are the thing I should remember. And extraction data, the new user will come. It can be me, it can be non-owner. It will match with the dead data. So what I'm trying to say is that we will add now score. You'll learn slowly. It is simple, and once we connect it, it becomes very easy. Okay. Let me try to add it. Data transformation. That search part is. Let me search for it only. Model scoring and evaluation, this one. Two things to note, we'll be using score model and finally we'll be using evaluate model. This will be connected actually. You'll see one. Last time I tried adding this component, score image model. You have to drag this one, score model. So if you try with the wrong component, every component has logic fit to it. Like it should have two input, one output. So this one we are using. Okay. All right. So what we have done till now, it's very simple. First time we are seeing, therefore it looks complicated, but it is really very simple. So I'm revising here itself now. We have dragged the actual data which we have. This data will be provided by you, either by your company or by someone. This will be we are creating a pipeline. It means data is ready over here. It will come over here. We drag drop our data. Now we want to split the data into two parts. We want to, for one for training, one for extraction. So for that we have used split component. This is 80% that will go to the training data, 20% will fit somewhere, the remaining data. Now for creating the algorithm model, whenever we use the word model, it means we are going to train. Model require two things. One is algorithm. For us, as it is a numeric, we'll be using linear regression, and the other one is the data set which we are passing. We'll connect now with here to here. After that we have a score model, we are evaluate model. Basically these two are, one for unlocking phone part, one means checking with the trained data. We have it not. All right guys, congratulations. We have understood most important part of it, which is using the how to use component, how to drag and drop. The later part is the simpler one. Let's see how we can do it. Now the machine complete data we will connect with here. Just a line is drag and drop. We used to work with BPM flow in my past, so that also work with this, the graphical only. So we connect from here to here. It means whole data is connected to split component. Now what to do now? All right, okay, so we have a split component ready over here. The next thing we have to do is train machine learning. Now this is a model, this is for training data, machine learning the fingerprint. So for that we have to provide, first part will be algorithm. Our case it is linear, so we connect algorithm with the machine learning with the model. And the second one is that 80% of the data, the first fingerprint, which the initial one, 80% of this data is going to the train model for machine to learn. Okay, these are the data you should know. All right, the next thing is score model. I'll drag it over here. Okay, next thing is score model here. Now in the score model, what we have to do, see, 80% of data is fed to the train model. Now remaining 20% data will go to for evaluation. These are fresh 20% data. You can think like new user can come or the same user can come. These are the data, 80% data now which machine learning knows or Azure pipeline knows, this model knows. This is the fresh 20%, the fresh guy is coming to unlock the phone. Okay, for checking. So what it basically will do, we'll connect the trained model over here. Why we are doing, see, because whenever we are trying to unlock a phone, behind the scene iPhone should know, okay, we have these fingerprints ready. Okay, so we have connected trained model, so it should first check, validate these two. Actually data set will be validated with trained data, and finally this will be connected to evaluate. It will evaluate over here. Cool. It looks complex initially, but it is very simple, and if you do it once with your hands, it will be the second nature for you. All right, so this step by step is written over here. Okay, you can just check. Means I tried to explain in each step what we are doing over here in points, and finally we have successfully connected all the component. Okay, we are right over here, we have connected all the component. Now it is important, see, once you will do 1-2 times, then it will become okay, it's simple. Now the one thing, when real time, when working in production, what you should know that see, our data is numeric, so we have chosen the linear regression. The art lies in choosing the right ML algorithm and the clean data. So whenever we get data from the customer, like these data, some data might be missing, some data might be in wrong format. Data should be clean, so we should implement some functionality to trim data or clean data or add some default value. For our case, this was the BMI report, sample report. Till here to here, from age to S6, all these are feedback, and this one is the label. Feedback means input, label means output. So we have already connected everything. Let me click the parameter, double click it. Okay, now I remember, this error came last time also. So see, whenever we connect a train model, we have just now seen that, okay, let's go from our data only, ML data, which we are seeing in the one which we are feeding, dev ML data. y is the label, whatever is output is called label, raster features, which is the input. So we have to choose the right label over here. So click over it or double click it. It asks for choosing a label. So let us click edit column, give y, save, and we can scroll it over there. Error is gone. Now let us click save and submit. What we are trying to do now is we have created this is a pipeline flow, ML pipeline flow. We have created it, we have connected it. Now we have saved it. Now we are about to submit it, and we are getting error. Okay, so this is expected actually. So let us click this error. So what Azure says, bro, please add the compute. So means, I mean, whenever we use a processor computer, we have to add some computation thing. Like in AWS we have T2 micro that is required to process everything. So we come over here and choose from the drop down we'll choose the dev ML compute. So this one will also be created like data. Let me show you over here. So like data, in the left we have compute over here. Basically there are 4 types. One which we have is dev ML compute. So we have it over here, and the same one is reflecting over here. Some processing will be here. The charge rate 28 GB, 14 GB, some data is here. Okay, let us select this, close it, and we see that now Azure side it is green. Let us click save and let us click what are these notifications. These were from my previous. Let us click submit. Now we are about to create now we have created a pipeline. Okay, machine learning pipeline, and what we do with the pipeline, we execute the run in it. Like whenever we deploy something, pipeline, production pipeline, dev pipeline, UAT pipeline, so something will run in that pipeline. So that running thing is called experiment in Azure. So we'll say we'll create a new pipeline, and let's see what naming convention I've used over here. Actually initially when we opened there were 2 workspace. Both are same. One before, in one we are using dev one, there we were using without dev. We'll just append dev name over there. We submitted it, this error came, we fixed it. Custom ML experiment, you can give any name. So let us give the name custom ML experiment, or run, any name you can give, but I prefer to add this also. Date will also come. See, date is coming. Dev run experiment, any name you can give of your choice, and yeah, rest are optional. We can click submit and it starts. Waiting from response. So now Azure part is started, so pipeline is initiated, custom ML dev is running. It takes some time and we have to wait till we get one message like in green, it is completed. Let us see in the over here. We are seeing this one, and then after some time we'll be seeing that we'll get completed status. This one will be quicker. It is submitted. we see it is still running, so this should be submitted. Then we'll go with the next step. Let us see, by that time let us see what we'll do now. So it is in completed state, and we have to do model evaluation. Correct. I'll be pausing for some time. Let us wait till this get completed. I think it will take a minute or two. Let's start when this is complete. All right guys, we are back now. So our pipeline is completed. We can see that status of the pipeline is completed. We get a notification as well. Yeah, so it is completed. So we can go see the pipeline status over here, job detail. So in the real time, in production, most of the time what happens is we get errors, right? So because over here for our case it is just we know that okay, we are connecting these data, but in real time when we are applying ML, data will be not as per our requirement. Some data will be missing, some data will be, so it will throw error. So we can see all the errors, everything over here. Let us click the job, custom ML dev. So how we went there? So we created the experiment. Now the whatever we have done till now, we have done inside designer, right? And we did it, saved it, submitted it. We on clicking that submit button, that when we were creating experiment, that pipeline which we just ran. So in Azure, job means everything is experiment. So every run in that pipeline is called experiment. This one was the experiment which we just ran. Okay, so why we are seeing all this? Okay, let's see, understand now. So in ML, every run is called pipeline. We go to job, this thing we have seen. Okay, so in real time, think like it is a production environment. So we get fail, error, no fail. Step by step will come here. So lot of hits we have done. By hit mean lots of pipeline we have triggered. There will be a list of run which we have done. Some will be in completed, some will be in failed. The time it was running, it was in this stage, running stage. So it will come here. What to note, what we can learn from here. Let's see that. First thing is you should note that if fail error is coming where we can click fail, we can see Azure gives good job that okay, this is the place where we're getting failed. You can see the actual logs here which help us to identify fix. So we have to do the backtrack. What is the error? Based on that we have to fix the data initially we provided. This one. Let us click the pipeline over here. Okay, so if it would have been failed, you entered here, you see the failed and logs over here. Now let us open this. Okay, so this is a tab which last time I closed it, so it didn't open. Initially it will be opened only. So based on here, that status error will come over here. Okay, now what to understand, what to learn from here is that, see, firstly though they provide us with a JSON data. What is JSON data? Whenever we'll be working, whatever we are doing now is doing training. Once everything will be done, we'll publish right now. We'll publish it. So for that we should know what is the data. Let us click this raw JSON. Alright. So this data is everything you need to know for the ML pipeline. Basically we feed as an input, run ID, UUID, then if there is parent-child relationship, we can see that over here. Logs will also come over here. Yeah, this is cool. So you have data, you have all the ML pipeline JSON ready, which can help us utilizing for the publish. This is one of the important thing to note. Then is pipeline parameter, output logs. You can see monitoring the errors will become easy. Metrics will be there. Okay, so what is a metric? You remember our data type is of numeric, so we used regression type model. If it had been classification, then true false boolean, then classification. So for numeric, they follow some metric. These I think mean, absolute error, relative error. For us need not know, but this is important factor. Why it is important? Because suppose we have predicted one line, okay, and some 1 or 2 data is coming out of that line. So distance between prediction line to that point is called the error. So it uses behind the scene these matrices. If there is some child job running one data starts another data, so these are the component we used, right? So if we linear regression was the algorithm, split data for splitting, training extraction, model was train models, score and evaluation model. Now cool. So now if everything is fine, by fine we mean green over here. So if error will come, we have to fix it first and do it. Means yeah, we have to fix it. That like we were getting warning error, we fixed it, then green tick come. So once it is green tick and everything is ready, you know now that okay, training is working fine. The next step is to publish the data. So how we can publish this data? For publishing the data, we click on this publish button. We click create new. Endpoint name I think I've given this. Okay, custom ML pipeline. Custom ML pipeline. For us, as it is dev, will hyphen dev. Alright. Rest will be same for us. Let us hit publish. Now the same will happen. Publish succeeded, go to the endpoint. Okay, this link will come over here. Now let us click this. So this one is the most loved part by the developer. Why? Because now we have a REST endpoint ready. So till now whatever we were doing in the training, we were actually trying to see okay it's working or not. Think like you have an iPhone, you have set your impressions fingerprint in that system and you are only trying to test it with your fingerprints if it is unlocking or not. Now once it is done, cool, you are satisfied, you'll no need to train more data. Then the next time we are using in real time, whenever you are carrying a phone, we are using fingerprint. So in real time, whenever we are using it, that is published. The testing one we were doing in the training. We come over here. So this endpoint is over here. Okay. We clicked this link on publish, then this link open. This was for publish, and if we scroll a little bit down, we see we have a swagger file. I mean it's just a data JSON to be used. Let's click this data, let's see what we have. So now this is in published state and we can see the data we have. I mean these responses we send when we create the pipeline in real time whenever we'll be validating them. So I mean, this is everything required for the ML pipeline in publish. We have it over here. Let us go over here. Yeah, so this was the data which we were seeing. Classification we have seen. We go to these component metrics. Now one little thing that we have to note, this is a little bit theory, but yeah, it's very, we have to understand. So when working in an application, like they ask what is F1 score, what is precision, what is it actually, a little bit of theory. So predicted label mean whatever is predicted. That line I was saying, you know, that if you click that line, that is the expectation from machine learning. True value, whatever we got. Some suppose 90% was fine, 5-6% was here and there. The distance between that predicted line and that is called true level. So whatever we actually got is true level. Whatever was machine predicting, it's called predicted label. Now for term, okay, this is actually a matrix. True negative, predicted value is negative, actual value is also negative. So it is true negative. False negative, predicted is negative but actual value is positive. Now false positive, predicted is positive, actual is negative. True positive, predicted is positive, actual is positive. No need to learn or something like that. Just you should know that what it is. What is important actually is this one. They ask a lot about this one, F1 score. What is F1 score? So now you know that, so you can refer anytime, come back here and see that predicted value. What are the four terms? So accuracy is proportion of accurate result. Precision is true positive by some algebra, maths is there. True positive by, based on which Azure calculates it. So this is precision, this is recall. So F1 score, so what I'm trying to say is that if in the application this data comes as F1 score. F1 score, what is basically F1 score is precision recall by precision plus recall. It's a balance between precision and recall. The lesser the F1 score, the good the model is for trend. If you have two phones over here, in one phone you have added just one fingerprint, in the other phone you have added more than 10-15 variations. The second one is good, so it will have lesser F1 score. First one is not so good, so it will have higher F1 score. Normally value is from 0 to 1, 0.8, 0.6, like that. So alright guys, we have learned everything we need to know about ML, creating an ML pipeline. So basically this was a little big, but it was fun as well, right? So what we have done, I'll just summarize in gist. So firstly what we did was we came to designer. In the designer we click this plus button and we created the, so we get two things over here. Left is data, right one is component. We pushed the data over there, and component we added lots of component over there as per our requirement. So what we have added, we have added actual data, split component, ML algorithm we used linear regression as the output was numeric. This one is numeric data, therefore regression. Model score evaluation. So we have created a training model. The training model, we fed that algorithm and first split of the data to it. Now we have model score. We can just see over here. Go to the job, click on this. Right, whole data comes over here, split. Then from we have algorithm, 80% data goes here and algorithm goes here. Remaining trained data goes to score model. One is trained model. Why it goes over here? Because machine should know from where to check, and the actual new fresh data, 20% data coming. Now it is connected to the evaluate model. Then after that, what we did, we saved it, we trained it. Once we trained it, we can see in the job. Once we have seen that it works fine, we published it by clicking the publish button. Once we click the publish button, we get a link. To that link we are reached here. We get an endpoint is very helpful when you want to consume it in our application. We see we get the data, JSON data is generated based on the ML thing we provide. So this is basically helpful when we want to hit the run experiment. What is an experiment? Whatever we run job in an Azure through the pipeline, each instance is called run ID or experiment. Cool. Alright guys, that's all for this video. I hope you learned it, and if you learned it, please like, share with your team, subscribe the channel. Thank you guys. Bye.